Alright, so for this chapter we're going to be looking at systems of equations and systems of inequalities. And a system is basically just, we've always been looking at one equation or one inequality at a time. These systems are looking at two or more equations or inequalities at a time. Alright, so we're going to start off by solving systems of linear inequalities, since we just did inequalities last chapter. Okay? So our steps to solving a system of linear inequalities is step 1, to get all the inequalities in slope-intercept form if they aren't already. If they are, good. If not, change them. Then you're going to graph each individual inequality with your proper shading. Remember, if it's y is less than or equal to, you're going to shade below it. If your inequality is y is greater than or greater than equal to, you're going to shade above it. And the key here, so now that you've done two of these, the overlapping part of the solution regions is the solution. Okay, so where the two shaded parts overlap, that's the final answer. Okay, so let's take a look at an example here. So number 1 here says graph the system of linear inequalities. Alright, so these are already both in slope-intercept form. So when I graph these, so once again, so y is less than 2x plus 2. We start off with our y-intercept, which is positive 2. Our slope is 2, which is 2 over 1. So I'm going to go up 2, right 1. Alright, and that is going to be the first inequality. And because it is less than, remember we use a dashed line there. Okay. Alright, now for my shading part, because it was y is less than, I'm going to shave below the line. Okay. Alright, so that's the first inequality. Now the second inequality is y is greater than negative 1/2 x minus 1. So we start on the y-intercept, which is at negative 1. Our slope is negative 1/2, which means we'll go 1 down, 2 to the right. So 1 down, 2 to the right. And this is also going to be a dashed line because it's greater than, not greater than or equal to. So that is how that line will go. Now for the graphing part, let me choose a different color. So now it's y is greater than. So we need to shade above this line. Okay? Alright, and so hopefully you see now, so we've got a lot of shading going on here. But the part where these blue and green parts overlap would be this section. So this area is the final answer for this system, both of these inequalities. Not that, only where they are the same. Okay? Alright, number 2, write a system of linear inequalities that defines the shaded region. So now we have to write a system. And you'll see that we have vertical line here, horizontal line here, and this is the final shaded region. That's the final answer where they overlap. Okay? So it doesn't matter which one you do first, so I'm just going to do the vertical line first. And if I remember my Hooyvux, remember vertical is x equals. Or in this case, x is on this side, so x will be greater than, and x is at negative 1, negative 2. Alright, so this line is x is greater than negative 2. And then we're going to go to the second line, which is this horizontal. Horizontal, your equation is y equals. So here y is at 1, and it's shaded above the line, so y is greater than or equal to 1 because it's a solid line. Alright, so that's just the same information. Here we're taking the inequalities and graphing it. Here it's graphed, we're writing the inequalities. Okay? And we could even do 3 of these. Okay, so if we graph this system has 3 inequalities here. Alright, so inequality 1 is y is greater than or equal to negative 3. So to graph that, once again, y equals is horizontal. So y is at negative 1, negative 2, negative 3. That would be a solid line because it's greater than and equal to. Oops, let me fix that. Alright. So this section would be shaded above it. So that would be all of this. Okay? Second inequality, x is less than 2. X equation is going to be vertical, that's your vux. So x is at 1, 2, and that's going to be a vertical line. It's going to be dashed because it's less than, not equal to. And because it's less than, we're going to color to the left on the x-axis. So this will be all of that. Okay? And lastly, we have y is less than x plus 1. So find your, it's getting kind of messy here, but there's your intercept of 1. The slope is 1. So it'll go like that. Dashed line because it's less than, not less than or equal to. And now when we shade this, now we're going to shade this under because y is less than. Alright, so there is a lot going on here. Alright, so the place where all three inequalities intersect, where they overlap, so in this case where I see my purple, my blue, and my green, that is going to be in this section right here. So here the solution to the system is any point in this region from those three lines. Okay? So if I were to just clean this up, okay? So yeah, let me just redo that so it's not so hard to look at here. So that would be the solution here. Okay? Alright, so building on this, so now it's asking us for a particular point. Okay? Number 4 is now saying, is 0, 1, is that a solution to this system? Alright, so basically what we have to do is we have to graph the system, find the area that's overlapping, and see if that point is in there or not. Okay? So let's graph these like we did. So y is less than or equal to 5 has x minus 2. Start off with your y-intercept, negative 2. And now my slope is 5 halves. So I'm going to go 5 up, 2 over. 2, 3, 4, oops, let me start over. 1, 2, 3, 4, 5, 2 over. Alright. Now this is less than or equal to, so we're going to use a solid line here. Alright, so that's our first inequality. But now we need to shade our region here. So now it's less than, so we're going to color under it. Okay? Now we're going to graph the second inequality in our system. So now it's y is greater than or equal to 1 half x plus 2. So we'll start with our y-intercept, which is at positive 2. And our slope is 1 half. So we're going to go 1 up, 2 to the right. And once again, a solid line because it's greater than or equal to. Okay? Now when we shade this part, okay, so now it's going to be above because it's greater than. So that means right here. Okay? So now if we clean this up, you'll see that the only place that it's overlapping is this small section. Alright, so if I clean that up, so that is our solution. Anything in that section where they're overlapping. So the point that they're asking us for is 0, 1, a solution. Well, 0, 1 is right here. That is not in the shaded region. So that means that if we write this out here, so the bottom line is 0, 1 is not a solution. Okay? And another way we can do this, like we've always been doing, is if we plug it in. If it's a solution, it will be true on both. Okay? So if I take the first inequality, 5 halves x minus 2, and if I plug in the x and the y, well, I should plug in 1 for the y, 0 for the x. Now if I simplify that, it's going to be 1 is less than or equal to 5 halves times 0 is 0 minus 2. And you see what this says? This says 1 is less than or equal to negative 2. 1 is not less than negative 2. So you'll see that 0, 1 is not a solution. Okay? And if I did it on the other one, plug in that same point, 1 is my y. Now it's 1 half x plus 2. Now it's going to say 1 is less than or equal to 0 plus 2. 1 is less than or equal to 2. That's correct. But because it's a system, it's got to be true for both at the same time. Okay? So graphically, we've seen that that's not a solution. Same thing when we plug it in. Okay? Alright, so now let's try this one. So now we have the same system of inequalities, but now we're checking a different point. Alright, so now what it's asking us here is negative 2, 1 a solution to this system? Okay, so let's go ahead and graph these again. Y is greater than or equal to 5 halves x plus 2. Start with your y-intercept at 2. Now the slope is 5 halves, so we're going to go up 5, right 2. Okay, now I can't go up 5. So we can kind of reverse it. Down 5, left 2. 3, 4, 5, 1, 2. Okay, so that means if I go up 5 and over 2, it's still the same slope. Solid line because it's greater than or equal to. And when we shade this in, it's greater than, so we color above it. Okay. Alright, now the second one here. Y is greater than or equal to 1 half x minus 2. So now our y-intercept is negative 2. Slope is 1 half, so up 1 over 2. Solid line because it says greater than or equal to. Okay. Now we'll shade this section. Now this one said y is greater than, so now we're going to color above all this. And we're going to see where the two colors overlaps. Alright, so you'll see that this section where the yellow and blue overlap to make green, that's the solution. So let's go ahead and clean all this up. Alright, so for this system of inequalities, this area is the solution. So let's look at where negative 2, 1 is on here. So start at the origin, negative 2, positive 1. Here's that point, and you'll see that that point is in the solution area. So that means that negative 2, 1 is a solution. Alright, that is an answer to the system, or both at the same time. Okay? And if I just wanted to prove that one more time by plugging it in, alright, so now if I plug in this point into the equations, y is 1, greater than or equal to 5 halves x, and x is negative 2, plus 2. This will be 1 is greater than or equal to 5 halves times negative 2 will be negative 5 plus 2. Bring down the 1 is greater than or equal to negative 5 plus 2 is negative 3. And 1 is greater than or equal to negative 3. So that checks out. And then if I do the second inequality in our system, y is the 1. Now it's 1 halves times x. X is still negative 2 minus 2. So bring all this down. 1 halves times negative 2 is negative 1 minus 2. And then negative 1 minus 2 is negative 3. And you'll see they both check out. So that's another reason why that's a solution there. Okay?